Preparing for a data engineering at PagerDuty interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you design a data model for PagerDuty incident and event data? I would separate immutable operational events from current incident state. An event fact table could contain event ID, service, timestamp, routing key, and payload metadata, while incident and escalation dimensions provide descriptive context. I would preserve status transitions in an incident history table rather than overwrite them. For analytics, I would create dimensional models for response time, acknowledgement, resolution, and service reliability. Clear grain, deduplication keys, and time-based partitioning would keep the model trustworthy and efficient. While answering, cover incident, event, service, escalation policy, and user entities. Define grain clearly. Discuss immutable event history, dimensional modeling, slowly changing attributes, partitioning, and analytical query patterns. Question 2. How would you build a reliable pipeline for PagerDuty event data? I would ingest events through a durable queue or streaming platform, write an immutable raw copy, and process them into validated curated tables. Each event needs a stable identifier so retries remain idempotent. Consumers should checkpoint progress, use bounded retries, and route poison messages to a dead letter queue. I would track freshness, throughput, lag, failure rates, and duplicate counts. Keeping raw data replayable lets me fix transformations without requesting producers to resend historical events. Make sure to cover ingestion durability, schema validation, ID impotency, ordering, retries, dead letter handling, late events, observability, replayability, and separation between raw, cleaned, and curated layers. Question 3. What strategies would you use to handle duplicate events in a data pipeline? I assume at least once delivery, so duplicates are normal rather than exceptional. I would use the producer's event ID when available and maintain a durable deduplication key, such as event ID plus source. Batch jobs can apply a windowed row number rule, while streaming jobs use a state store with an expiration policy. I would avoid deduplicating solely on timestamps because legitimate repeated events can look identical. Metrics should expose duplicate rates and unexpected identifier reuse. In your answer, discuss at least once delivery, natural versus generated event identifiers, deduplication windows, unique constraints, state stores, replay behavior, and the difference between event duplication and legitimate repeated activity. Question 4. How do you handle late arriving and out-of-order events in streaming systems? I would use event time for business calculations and processing time for operational monitoring. Watermarks estimate when a window is complete, while an allowed lateness period lets delayed events update aggregates. For incident timelines, I would retain enough state to accept corrections and publish revised results or compensating records. The right lateness threshold depends on observed delivery behavior and reporting needs. I would document whether downstream consumers see provisional or finalized metrics. Be sure to mention event time versus processing time, watermarks, allowed lateness, window updates, corrections, state retention, downstream consistency, and business requirements for incident timelines. Question 5. How would you design an incremental ETL or ELT pipeline for large incident tables? I would prefer change data capture when available because it captures inserts, updates, and deletes reliably. Otherwise, I would use a high watermark such as an updated timestamp, with a small overlap window to protect against clock skew and late commits. The destination merge must be idempotent and preserve deletion semantics. I would partition by event date, monitor extracted and loaded counts, and support parameterized backfills without disrupting the normal schedule. Focus on change data capture, high watermarks, update timestamps, deletes, overlap windows, idempotent merges, backfills, partition pruning, and validation against source totals. Question 6. What is your approach to data quality for operational analytics? I define quality checks at ingestion, transformation, and serving layers. Examples include unique event IDs, non-negative durations, valid service references, expected status transitions, freshness limits, and reconciliation with source counts. Checks should have owners and severity levels. A broken primary key blocks publication, while a small anomaly may warn. Invalid records go to quarantine with enough context for repair. I also publish quality metrics so consumers can judge whether a dataset is safe to use. Make sure to cover completeness, uniqueness, validity, consistency, freshness, referential integrity, business rules, severity thresholds, ownership, quarantine paths, and alerting that avoids noisy failures. Question 7. How would you optimize a slow analytical query over billions of events? I would start with the execution plan and identify scans, expensive joins, shuffles, and skew. Then I would filter on partition columns early, select only required columns, and improve clustering or sorting for common predicates. Large repeated aggregations may justify summary tables or materialized views. I would check join cardinality and broadcast only genuinely small dimensions. Finally, I would benchmark before and after using realistic data, measuring latency, scanned bytes, concurrency, and cost. Discuss query plans, partition pruning, clustering or sorting, predicate pushdown, column selection, pre-aggregation, join cardinality, approximate functions, caching, and validating improvements with representative workloads. Question 8. How do you choose between batch processing and stream processing for PagerDuty analytics? I choose based on the business latency requirement, not fashion. Real-time alert volume, ingestion health, or active incident views may need streaming. Monthly reliability reporting can usually use batch because it is simpler, cheaper, and easier to reconcile. A hybrid design is often strongest. Stream provisional metrics for responsiveness, then run batch corrections for authoritative results. I would also consider replay requirements, state management, team expertise, and whether consumers can tolerate eventually consistent numbers. In your answer, compare latency, cost, complexity, replayability, correctness, operational burden, event volume, user expectations, and hybrid architectures using streaming for operational signals and batch for authoritative reporting. Question 9. Explain exactly once processing and whether you would rely on it. Exactly once means each logical record affects the final result once, even when failures cause retries. In practice, it requires coordinated checkpoints, transactional writes, and a compatible sync, so platform-level guarantees may not cover external systems. I generally design for at least once transport plus idempotent syncs, deterministic transformations, and deduplication. That approach is easier to reason about across boundaries. I would still use native transactions where useful, but verify end-to-end behavior with failure and replay tests. Cover at most once, at least once, and exactly once semantics, transactional boundaries, sync ID impotency, checkpointing, failure scenarios, practical limitations, and why end-to-end correctness matters more than platform labels. Question 10. How would you manage schema evolution for event payloads? I would establish an explicit schema contract and validate messages near ingestion. Additive, nullable fields are usually safest. Renaming or changing types requires versioning and coordinated migration. A schema registry can enforce compatibility rules and provide discoverability. Consumers should tolerate unknown fields, while producers should publish examples and test against important consumers. I would roll out readers before writers, monitor rejected records, and retain raw payloads so historical data remains recoverable during evolution. Be sure to mention schema registry or contracts, backward and forward compatibility, additive changes, versioning, nullable fields, producer coordination, validation, rollout sequencing, and handling unknown fields. Question 11. How would you design data pipelines for PagerDuty's reliability and availability expectations? I would isolate ingestion, processing, and serving so one failure does not cascade across the platform. Durable queues absorb bursts, checkpoints support recovery, and consumers scale independently. Multi-zone deployment, health checks, backpressure, and dead letter handling improve resilience. I would define SLOs for freshness and completeness, then alert on error budgets rather than every transient issue. If analytics is unavailable, raw events must remain durable and incident-critical operational paths must continue unaffected. Focus on failure isolation, durable queues, multi-zone deployment, backpressure, graceful degradation, replay, idempotent recovery, service-level objectives, dependency monitoring, and protecting incident-related workloads from analytics failures. Question 12. What observability would you add to a production data pipeline? I monitor pipeline health from source to serving layer. Core signals include records received and written, freshness, processing latency, consumer lag, retry rates, dead letter volume, schema violations, and reconciliation differences. I add structured logs, trace identifiers, dashboards by stage, and lineage linking failures to downstream datasets. Alerts should be actionable and tied to SLOs, with runbooks explaining diagnosis and replay. Cost and resource utilization also matter because silent inefficiency becomes an operational risk. Discuss freshness, completeness, volume, latency, consumer lag, error rates, schema failures, lineage, cost, dashboards, actionable alerts, runbooks, and correlation between pipeline health and user-facing impact. Question 13. How would you implement data governance and protect sensitive customer information? I would classify fields before designing storage and apply least privilege access through roles, service identities, and environment separation. Data should be encrypted in transit and at rest, with sensitive columns masked or tokenized for analytics. Retention and deletion policies must be enforceable across raw, curated, and derived datasets. I would log access, review permissions periodically, and minimize copied personal data. Governance should be automated in pipeline checks rather than left to documentation alone. In your answer, cover data classification, least privilege, encryption, masking, row or column policies, retention, deletion workflows, audit logs, environment separation, access reviews, and privacy-aware analytical design. Question 14. How would you calculate incident response time accurately? First, I would define response time as acknowledgement timestamp minus triggered timestamp, using a consistent event time convention. Resolution time would similarly use the resolved transition, with explicit rules for reopened incidents and missing transitions. I would store timestamps in UTC, preserve the full status history, and flag impossible sequences instead of silently correcting them. For reporting, I would calculate medians and percentiles by service or priority, because averages can hide severe responder experiences. Mention precise event definitions, acknowledgement and resolution timestamps, time zone handling, missing or contradictory records, reopened incidents, pauses, percentile calculations, deduplication, and validation with operational stakeholders. Question 15. How would you investigate a discrepancy between a dashboard and the source system? I would reproduce the dashboard query and document its metric definition, filters, time zone, and refresh timestamp. Next, I would compare counts and key totals at every pipeline boundary, checking duplicates, missing partitions, late events, joins, and deletion handling. I would inspect recent code or schema changes and validate a small sample against the source system. If the dashboard is stale but correct historically, I would distinguish freshness from accuracy and communicate the impact before applying a fix. Be sure to cover metric definitions, time zones, filters, freshness, source to target reconciliation, duplicates, late data, joins, deleted records, transformation versions, and communicating uncertainty clearly. Question 16. How would you design a backfill for several months of historical event data? I would parameterize the pipeline by time range and run the backfill in isolated, partition-sized batches. The transformation must be deterministic and idempotent, with merge keys preventing duplicate outputs. I would process dependencies in order, throttle resources to protect real-time workloads, and write results to temporary or versioned locations first. Before publishing, I would compare counts, totals, and sampled records with expectations. Checkpointed execution makes failures restartable without repeating completed partitions. Focus on scope isolation, immutable raw data, idempotency, dependency order, resource throttling, partitioned execution, validation, duplicate prevention, cost control, and protecting current production workloads. Question 17. How would you reduce the cost of a cloud data platform without hurting reliability? I would begin with cost attribution by pipeline, query, team, and storage layer. Common improvements include columnar compression, partition pruning, lifecycle tiers, retention enforcement, and eliminating duplicate datasets. I would right-size compute, schedule non-urgent jobs, and use autoscaling or interruptible capacity where recovery is safe. Query limits and curated summary tables can reduce repeated scans. I would never optimize blindly. Freshness, recovery objectives, and customer-facing reliability define the acceptable savings. Discuss workload measurement, storage tiers, partitioning, compression, autoscaling, spot capacity where appropriate, query governance, retention, materialization choices, workload isolation, and cost-to-value trade-offs. Question 18. What testing strategy would you use for data pipelines? I use several layers of testing. Unit tests verify transformation logic with edge cases such as duplicates, nulls, late records, and reopened incidents. Contract tests protect producer and consumer schemas, while integration tests exercise storage, checkpoints, and permissions. I add reconciliation tests for counts and aggregates, plus property checks such as non-negative durations. Before production, representative fixtures and historical samples catch regressions. After deployment, data quality monitoring provides protection against valid-looking but incorrect outputs. Include unit tests for transformations, contract tests, fixture-based integration tests, property checks, reconciliation, regression tests, failure injection, representative edge cases, deployment gates, and production monitoring. Question 19. How would you make a data platform easy for other engineers and analysts to use? I would publish curated datasets with clear grain, definitions, owners, freshness, quality status, and example queries. A catalog and semantic layer reduce conflicting interpretations of metrics such as acknowledgement time. Access should be self-service within governance boundaries, and stable interfaces should have versioning and deprecation notices. I would expose lineage so users understand upstream dependencies. Finally, I would measure adoption, support questions, and failed queries to prioritize improvements based on real usage. Talk about well-defined datasets, ownership, documentation, semantic layers, cataloging, examples, access workflows, self-service quality indicators, stable interfaces, deprecation policies, and feedback from actual consumers. Question 20. Describe a data engineering project you would propose to improve incident management insights at PagerDuty. I would propose a near real-time service reliability dataset that combines incident transitions, alert volume, escalation paths, and ownership metadata. The first release would answer which services experience repeated incidents and where acknowledgement or resolution slows. I would build a replayable ingestion layer, curated dimensional tables, and governed metrics for response percentiles and incident recurrence. Success would mean faster analysis and trusted adoption, measured through query usage and reduced manual reporting. I would start with one workflow, validate definitions with responders, then expand carefully. In your answer, connect customer value to measurable outcomes. Explain source systems, architecture, metrics, rollout, reliability, privacy, stakeholder alignment, and how you would learn from an initial focused release. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.